Do you
Okay.
record in this class because my class is too naughty?
No. Your class is nice. Yeah, I just yelled at you today because I just couldn't
No,
take it
no,
anymore.
not that. My
Okay.
dirty mouth.
Oh no, yes, that too. Okay, so sorry, I just started recording this. If you're watching this from home, okay, send me an email. I'm not going to send this to you unless you ask. Okay, but this is extra credit. Okay, what you need to do is color this. I will send you a digital copy. Okay, the only thing I ask is that these little Y's, the antibodies, are colored green. If it looks pretty, okay, and I will show you Bella's, like right here. Look at that, so nice. She did it right. There's the Y right there. Okay, that is an 8 out of 0. So this is extra credit. We will be talking about this thing in class. But if you want the extra credit, email me. I'm not just throwing it out there for you because I want to see who's actually watching these videos. Girlfriend. Why did I say that? Okay,
You have to tell them it's due Friday.
it's due Friday. Okay, at the beginning class, not the end of class, not the end of the day.
Not the middle
Okay,
of the
like-
class.
Yeah.
Beginning. Not even 1/4 into class. Beginning. Right when the bell rings. So Trinity, that means you can't be late.
Every stinking day, Trinity. Okay, I ain't taking it anymore. All right, let me show you something. These videos, I don't know what it is about them, if it's just the visual part of me, but I love them.
I'm gonna see if they think this is bogus
their-
too.
This Lace is all fired up about the immune system. Ethan McWilliams loves this crap too. If you've ever watched these Kyrgyzstans, they're awesome. There's so many different things, and they're great graphically, but they also explain things like, so you're like, oh, I get this. I mean, they cover, their newest one is Gold Apocalypse. What if the world turned into gold? What happens if we nuke the moon? Okay, let's see.
Can I tell them my theory?
Not yet. Okay, what are we?
I'll tell you after the video.
Oh yeah, man, they're good. The wormholes one's really good. Like you could like do a deep dive in these things. Like once you watch one, you're like, oh, the narrator's like, there's something about him. I like him.
His voice is comforting.
Yeah, I think so too. Okay, but there's also some little Easter eggs in here. But when I saw this for the first time, I was like, holy cow, I have to show this the rest of my life. This is really one of the first times where I was like, lots of light bulbs went on. We're going to watch this as an introduction. I've done this before where I've explained it, then watched it. I've watched it first and then explained it. I've watched it first, then explained it, and watched it again. Okay, I don't know what works best, but we're going to watch it as an introduction. Maybe get fired up like Lace and thinks it's all BS. Okay,
It is.
I do like the little Pokemon there. Okay, happy 25th, Pokemon. 25 years, kids. Can you believe it? Okay, here we go.
Under attack. Billions of bacteria, viruses, and fungi are trying to make you their home. Still, our bodies have developed a super complex little army with guards, soldiers, intelligence, weapons factories, and communicators to protect you from, well, dying. For this video, let's assume the immune system has 12 different jobs. For example, kill enemies, communicate, etc. And it has 21 different cells and 2 protein forces. These cells have up to 4 different jobs. Let's assign them. Here are the interactions. Now, let's make this understandable. First of all, let's add colors to the jobs. Now, let's illustrate the cells. The central color represents the main job of the cell, while the surrounding ones represent secondary duties. Now, the immune system looks like this. Now, the interactions. Isn't this complexity just awesome? For this video, we will only talk about these cells and ignore the rest. So what happens in the case of an infection? It's a beautiful day when suddenly a wild rusty nail appears and you cut yourself. The first barrier of the immune system is breached, your skin. Nearby bacteria seize on the opportunity and enter your wound. They start using up the body's resources and double their numbers about every 20 minutes. At first, they fly under the radar, but when a certain bacteria population is reached, they change their behavior and start to damage the body by changing the environment around them. The immune system has to stop them as fast as possible. First of all, your guard cells, known as macrophages, intervene. They are huge cells that guard every border region of the body. Most of the time, they alone can suffocate an attack, because they can devour up to 100 intruders each. They swallow the intruder whole and trap it inside a membrane. Then the enemy gets broken down by enzymes and is killed. On top of that, they cause inflammation by ordering the blood vessels to release water into the battlefield, so fighting becomes easier. You notice this as a very mild swelling. When the macrophages fight for too long, they call in heavy backup by releasing messenger proteins that communicate location and urgency. Neutrophils leave their patrol routes in the blood and move to the battlefield. The neutrophils fight so furiously that they kill healthy cells in the process. On top of that, they generate barriers that trap and kill the bacteria. They are indeed so deadly that they evolved to commit suicide after 5 days to prevent them from causing too much damage. If this is not enough to stop the invasion, the brain of the immune system kicks in. The dendritic cell gets active. It reacts to the signals of the soldiers and starts collecting samples from the enemies. They rip them into pieces and present the parts on their outer layer. Now, the dendritic cell makes a crucial decision. Should they call for antivirus forces that eradicate infected body cells or an army of bacteria killers? In this case, antibacteria forces are necessary. It then travels to the closest lymph node in about a day. Here, billions of helper and killer T cells are waiting to be activated. When T cells are born, they go through a difficult and complicated training process, and only a quarter survives. The surviving cells are equipped with a specific setup. And the dendritic cell is on its way looking for a helper T cell with a setup that's just right. It's looking for a helper T cell that can bind to the parts of the intruders which the dendritic cell has presented on its membrane. When it finally finds one, a chain reaction takes place. The helper T cell is activated. It quickly duplicates thousands of times. Some become memory T cells that stay in the lymph node and will make you practically immune against this enemy. Some travel to the field of battle to help out. And the third group goes on to travel to the center of the lymph node to activate a very powerful weapons factory. Like the T cells, they're born with a specific setup. And when a B cell and a T cell with the same setup meet, hell breaks loose. The B cell duplicates rapidly and starts producing millions of little weapons. They work so hard that they will literally die from exhaustion very fast. Here, helper T cells play another important role. They stimulate the hard-working factories and tell them, "Don't die yet, we still need you. Keep going." This also ensures that the factories die if the infection is over, so the body doesn't waste energy or hurt itself. But what is produced by the B cells? You've heard of them, of course. Antibodies, little proteins that are engineered to bind to the surface of the specific intruder. There are even different kinds of antibodies that have slightly different jobs. The helper T cells tell the plasma cells which type is needed the most in this particular invasion. Millions of them flood the blood and saturate the body. Meanwhile, at the site of infection, the situation is getting dire. The intruders have multiplied in number and start hurting the body. Guard and attack cells fight hard, but also die in the process. Helper T cells support them by ordering them to be more aggressive and to stay alive longer. But without help, they can't overwhelm the bacteria. But now the second line of defense arrives. Billions of antibodies flood the battlefield and disable lots of the intruders, rendering them helpless or killing them in the process. They also stun the bacteria and make them an easy target. Their back is built to connect to killer cells, so they can connect and kill the enemy more easily. Macrophages are especially good at gnoming up the bacteria which antibodies have attached to. Now, the balance shifts. In a team effort, the infection is wiped out. At this point, millions of body cells have already died. No big deal, the losses are quickly replenished. Most immune cells are now useless, and without the constant signals, they commit suicide, so as not to waste any resources. But some stay behind, the memory cells. If this enemy is encountered ever again in the future, they will be ready for it and probably kill it before you even notice. This was a very simplified explanation of parts of the immune system at work. Can you imagine how complex this system is? Even at this level, when we ignore so many players and all the chemistry. Life is awfully complicated, but if we take the time to understand it, we always encounter endless wonders and great beauty.
Man, I love those. All right, so Lace is like, how they figure this out?
No.
Way. Wait, okay.
Let me tell you.
All right, tell me.
Here's my theory.
Yeah.
How this is bogus. This is the biggest bogus ever. Not just this, everything. Because how in the world, if these cells are so, I have a headache. If these cells are so small, how do they know that they do this? You can't see all those. I don't want to hear it, Addison. This is
Just
so
let her
what?
believe. She's
They-
also.
They literally just bacteria in my body and they see all this going on. No. How do they know how to cure so many things? It's literally bogus. They're lying to me.
Yeah, Lace, honestly, I'll tell you the truth. It's Bill Gates and the microchips that he's putting inside.
Literally.
all of us.
I don't believe in that either. There's a lot of things that I don't believe in because there's no way it makes sense. Like Bluetooth. How does that work? A plane? How does that stay afloat? A boat? How does that work?
We're all dead anyways. It's just
See-
one big dream.
CDs and movies? How do they know?
So when you go to the doctor,
These things don't make
when
sense.
you go to the doctor, they feel your neck.
I
okay?
actually have a
Okay,
list of things that don't make
like,
sense to me.
For a while, like, man, like my doctor would check like underneath my armpit. Like I would get this thing. My son Linus, okay, for a while had this bump on the back of his head. And we were like, oh, what is that? The doctor's like, well, it's a lymph node. And we're
Okay,
like,
back down to my hole. Bye,
what's
guys.
going on? We're like, what's going on with this? And excuse me, the doctor's like, well, I don't know. Just watch it. Your body's doing something, right? Addison, what were you gonna say?
There's a concept in physics.
Yeah.
It's called quantum tunneling.
Okay.
I couldn't buy into for the longest time, but it's basically where a particle can pass through an impenetrable barrier.
Yeah.
Insane.
Yeah. There's a lot of stuff that like I'm just like, okay, scientists, I'm gonna trust you on this one. But like, yeah, it's a hard thing to know. Like, you know, like the doctor's like, hey, look, like I don't know what's going on, but like your body's doing its thing. When I cut myself, okay, I bleed, but my body, it feels hot, right? You ever felt hot like on a wound? It also gets red. That's your body responding. That means it's doing its job, right? Your immune system is literally working. Okay. This time of year, people's allergies start acting up. Some people take an antihistamine. Okay. Is a histamine a good thing or a bad thing? What do you think? That's what I thought, right? Antihistamine. I want to get rid of my histamines. Histamines are good. Okay. But we are not having it, I guess is the best way to put it, because I'm all stuffy. So I'm going to take a medicine that prevents my immune system from doing its job. Why is my histamines active? Because they're fighting off some foreign thing in my body, whether that's tree pollen or goldenrod or any of those things. Yeah. Say that again, man.
Like,
Alcohol like booze? Talking like fireball
No,
shots?
no, like rubbing
Oh, sorry, I was like, yeah. What's that?
what's in that?
It's an antiseptic. I don't know what's in it that like causes it to do that.
Why does it burn? Or like when it burns
That's a
out,
great-
like,
So this-
Yeah.
Now might be a good time to pull up that George Carlin.
Oh yeah, should do that tomorrow. Should. Can I even show that in school? I don't know.
I don't think.
I don't
you should.
think I can. Yeah, right. Yes.
So when you do that, like you put like peroxide or whatever on stuff, and like the bubbles come.
Yeah.
My mom always says like the infection getting out of it, like. what
Not
is-
necessarily, because like, you know, you can put peroxide on lots of stuff and it bubbles, you know?
Yeah.
That's just a reaction, but it's not necessarily, I mean, that's a nice thing to say, but you can't like 100% say it's getting the infection. I don't know what it is about the isopropyl alcohol that's in it that makes it like kill this bad stuff. I accept it to be true, but I can't tell you chemically what does it. And that's out of my scope. But I love the question. What do we got here? I got the, so all these like little things are the lymph nodes, but look at some weird stuff here, like large intestine, small intestine. There's the spleen, okay? And then tonsils, okay? A lot of people don't realize your tonsils are one of your first lines of defense in your digestive system. It's an immune thing. So if you have your tonsils removed, you are immunocompromised, which is interesting to think about, right? All right, so what's the lymphatic system do? It's mostly these vessels that send a fluid around the body, okay? That fluid can collect, and I just wrote myself a note while we were watching this movie. Tomorrow, I will include some pictures of elephantiasis. I don't know if anybody's ever heard of this, but it's like a swelling in the legs, but I've also seen like a guy literally sitting on his own testicles because his testicles swelled up to like beach ball size. Abby, have you seen this? You're like shaking your head. You're like, yeah, I've been there. Okay. All right. But what everybody knows with the lymphatic system is it's your defense mechanism, right? It's going to defend against stuff. It is a one-way thing. It flows to the heart. Okay. And I'm going to jump ahead to this picture. Okay. Here's this arrow. Notice there are these valves. Okay. But here's my challenge to you today. Okay. I'm going to show you this picture. I'm going to shut the lights. Take a look at this. This picture freaks me out. Okay, and a couple people are like, did you just get this picture off the internet? This is from my textbook. Okay, and there's something weird about this.
Stop calling me out, Bernard.
Okay. I didn't say your name. Okay, what's weird about this? Don't say the pubes either. Earlier someone was like, pubes? Is it all the pubes?
Is it like the first layer of? Kind of.
You're
Oh
on the
no,
right.
it's the discoloration because if the area drained by that fluid isn't going to that part of that body. So
Oh,
it's
yeah,
gonna be
nice, nice. This is actually showing, the coloration is showing that this is the area drained by the right lymphatic duct. This is the area drained by the thoracic duct, okay? Right, so we have two ducts, 1 and 2. Okay, but why do I find this weird?
It's not like half and half.
It's why is it not symmetrical? We have one eye, one ear, one nostril, one boob, right? One hand. Like it should, you would think it'd be right down the middle, right? I cannot find anywhere an answer, and I've tried to do a deep dive in the literature to figure out why it is not symmetrical. Maybe we don't know. Maybe my internet skills are not good. I would love it if someone's like super bored. Find out why the thoracic ducts are not symmetrical. Okay, it's the weirdest thing to me. Maybe we don't know. This could be your PhD doctoral thesis, right? Okay, but really interesting to me. All right, let's talk about the organs. This, and I found this picture. I think this picture is so cool. Okay, so like one of my favorite pictures of just anything in an anatomy. Okay, this is in your intestines, and these things are Peyer's patches. We find these in the appendix, okay, and they are a defense mechanism, or it's a way to help fight off some microorganisms. Okay, these little fingery kind of things are called villi, and this picture was taken in the small intestine. Okay, so let me tell you a little bit about your digestive system. I eat the food, it goes down my esophagus, it goes into my stomach, the stomach churns it up, it sends it to the small intestine. The small intestine absorbs all the nutrients and sends them to the bloodstream. So if I want sugar in my cells to make ATP, it has to go through this. You cannot live without your small intestine. You can live without your large intestine. In fact, your large intestine, I have a friend who doesn't have one. She will never poop a solid poop the rest of her life, okay? Like literally, they removed all of her large intestine and connected her rectum with her small intestine. So her food goes down her esophagus, her stomach, her small intestine, rectum, and then out to the world, okay? Your large intestine absorbs water, okay? Think about how awesomely placed these are. You cannot live without food in your blood so that you can make ATP, yet things will want to kill that, right? Things will want to like hurt these. We've got a nice line of defense. For a long time, we didn't know these existed. Peyer's patches, so stinking cool. Okay, but let's talk about the tonsils. Okay, anybody in here not have their tonsils? Okay, a few of you. Okay, there's 3 sets: the palatine, the lingual, and the pharyngeal. Here's where they are. Palatine's what you see. There's your teeth, there's the hard palate. Here's your nose. I'm picking this guy's nose, right? Here's the pons. There's the spinal cord. Here's the cervical vertebra. Okay. There's the air tube. Here's your epiglottis. These are at the back of your nose, and these are at the back of your tongue. This is another picture. If I remove the uvula, I can see the pharyngeal, but the ones that everybody sees are the palatine. You open up your mouth, and if your tonsils are swollen, you've seen these. Now, some people have removed the pharyngeal, but you call them something else. What do you call them? Starts with an A. There's the pharyngeal. There's the uvula. Here's the A one. Adenoids. Have you heard of that? Right? Yeah, in your nose. They're up in your nose, right? So here's where they are, way back deep. You don't see these. All the way up there. So a lot of people are like, oh yeah, I got my adenoids removed. Not realizing that those are tonsils, right? That's way in the back. Okay. Here's what enlarged tonsils look like. You can have the enlarged adenoids. Sometimes you can see them at the uvula, but for the most part, people see them right there. There's your lingual tonsils.
Why do they get like,
Okay.
large? Like, why do they get like, what
So they
causes-
get large because they're fighting off. It's a line of defense. Yeah. Yeah. We'll look at some of those. Absolutely.
And when they get like bigger, why do people have to get them removed?
Yeah. Okay. So some people get them removed because they have issues with them. They're actually causing some breathing problems. My brother had mono and had to be hospitalized when he was a senior in high school because his tonsils were so swollen that he had a very small area to breathe. Yeah, kind of with you too. Yeah. Yeah. I think though, correct me if I'm wrong, but I think they're doing less tonsil removal. Right? It was kind of a trendy thing for a while, which is weird. Now they're kind of like saying like, we could treat your issues. Where it used to be like, oh, let's just take them out. Now they're kind of like realizing, maybe we should probably leave them in. Yes.
I had strep throat like 15 times in 1 year.
That's why they finally took
Yeah,
them out.
and I had to go to the emergency room. Like, I would wake up in the middle of the night and my whole airway was blocked.
Oh, dang, girl. Oh, yeah, that's a bummer. A lot of people are like, so what is the difference? Like, how do you know you have strep throat? Okay, what if it's just viral? So strep throat is caused by bacteria. Okay, so here's bacterial causes a lot more stuff, but typically it's like the coloration. When bacteria grows, like fungi, it creates like a mold on top, right? Okay, that is, but bacteria will do the same thing. Okay, when that happens, okay, you get white spots on your tonsils, but also on your tongue and your uvula, which is the ball sack at the back of your mouth, right? Okay, that also swells up. Okay, viral does not do that. Viral, usually just a red swollen tonsil, okay, and your throat is swollen and itchy and gross, right? That white stuff. Now, like to truly know if you have strep, you have to take a swab test, right? Peace out, everybody. Thanks for paying attention today. I appreciate it. You don't know how many times I want to kick you down here. Just